In this movie, we're going to look at the design of the structure of our database system. We're going to sketch this out as an entity relationship diagram. First of all, let's take the customer entity and start to sketch in all the entities that we think should make up this particular database. We need customers and videos. Those are perhaps the most basic elements of our database. We also need to be able to split videos up by genre. Typically, a video shop will divide their stock on the shelves on the basis of genres of videos. So it's very important to be able to point a customer to the right section of the shop, and to make it easier when a video comes back in to know where to put that particular video. We also need some way of allowing customers to ask vague questions such as, what was the movie with John Travolta in it that was a kind of a trashy action movie? And for the system to be able to return some kind of intelligent response. We therefore have to be able to store some information about the videos, such as which actors appear in the particular videos that the customer is searching for. Another possible entity is the fine that the customer has to pay. That could be an important one. And we also have the employee entity and perhaps the boss entity. Now all of these are simply ideas that I've sketched down, some of them translated directly into tables that are eventually used in the resultant database. Some of them, however, as we'll see in a moment, changed through the process of thinking about how the different entities relate to each other and the most logical way to structure the data. Videos need to be linked to customers. We'll start sketching in the relationships here, and this will often help us notice as we hit problems and have to restructure our entities. One customer can have many videos out, so we use a one-to-many relationship there between videos and customers. Genre, each video has to be connected to a genre, so again we have a one-to-many relationship there as well. We also need to connect videos with actors, and presumably, since there's more than one actor within each video, we need a one-to-many relationship there as well. The problem here is the fact that we have many actors and many videos. So we could have, for example, an instance in which the same actor appears in different videos, but the same video also contains many actors. So we have a problem here with the structure. Way to solve this problem would be to include an extra conceptual entity called film actor, and this film actor entity will essentially act as a bridge between the actor entity and the video entity. This is to avoid problems that would arise if we tried to create a many-to-many relationship, something that's not possible because of our database architecture. We can fill in the lines here, and there it becomes obvious that the problem is solved by using the bridging table. Another issue arises with the fact that some customers may not know who acted in the film, but they may know who directed it. Or maybe they were so impressed by one particular film and the direction within it that they want to find out what other movies this particular director has made. So my first thought was to go through the same process of creating a director entity that would then presumably have to have a film director bridging table between director and video. I instead decided to generalize the actor entity into an artist entity, and then we'd have the bridging table would similarly be generalized. This would also allow the flexibility of actors who are also directors or also screenwriters and so on. It would allow us to get over the problem of the instances in which an actor directs and stars in the same movie. We'll look at exactly how these relationships work and at what point the nature of the work that the artist has done on the video will be included within the table. We'll look at that later on down the track.